Hi there, welcome back. Today we are going to talk about Google's agent to agent protocol. This was announced by Google recently, just a week back, and this protocol actually addresses the challenges of agent to agent communication. So today we are going to discuss about what are the challenges today we have with agent to agent communication and how Google agent to agent protocol is going to actually address that challenge. What are the different components of Google's agent to agent protocol, and then we'll also have a demo and code walkthrough of where we will build two agents, and then we'll see how a another agent, like third agent, which is like client agent, can actually communicate with these two agents seamlessly using the Google's agent agent protocol. So stay with me till the end so that we can uncover the all the different components and the working of Google's agent protocol. So with that, let's get started. So before we get started, I would encourage you to watch other videos on this channel, especially on the AI agent orchestration evaluation, and then model context protocol, and then AI agents explained from concept to practical implementation. These three will give you a solid foundation on AI agents, the model context protocol. That would really benefit you when you're actually working on the Google's agent agent protocol. Let's look at some of the agent to agent communication challenges what we have today, right? Just take an example, like we are having three agents here: a market research agent, which is expert in actually conducting the market research by different companies or different segments or different verticals. It uses some set of tools and host of other external APIs and then a GPT model to achieve that. Then we have a lead generation agent, which is expert in generating the leads. It also uses some tools, say it uses some DeepSeek model here. And then we have an email draft agent, which is expert in actually drafting emails, for that particular company, branding or tone, everything. Maybe it is using a Gemini model, or it might be using a model which is actually fine tuned for a particular company or maybe a set of companies. Now I'm having a sales agent. Now the sales agent has to consume these three agents. The only way today we have is that maybe this market research agent has to expose some sort of an API, and then the sales agent has to invoke that API with these three agents, and then which involves a lot of integration between sales agent and market research agent. And for example, if lead generation agent has to consume from market research agent, again there is a one more communication between this and that. And if email ref agent has to actually talk to a lead generation agent, again there's some sort of communication between these two things. You could see that a lot of communication happening between all these things. The challenge is that it involves a lot of integration code, a lot of plumbing required between these agents to achieve this. That's what we are going to see how a Google's agent agent protocol can actually address this particular challenge. So let's take a moment to talk about the real world pain points of building a multi-agent systems today, right? Number one, too much glue code. Every time you want one agent talk to another, you end up writing lots of custom integration logic. You name it: serialization, deserialization, authentication, read writes, logging. So like too much of code written for any communication, and this keeps growing. It becomes quite unmanageable after some time. Then right now the standard way for agents to interact is by exposing a REST API or maybe some RPC endpoint. That means each agent not only has to expose an API, but other agent must be programmed to know exactly how to consume this endpoint. Payload structure, error codes, it's all manual. Third challenge is tight coupling. The moment an agent changes, say it upgrades its API or it modifies response schema, everything that talks to it, it breaks, right? It's like a walking on eggshell. You change one thing and suddenly three other agents are failing downstream. And then there is no shared understanding. There is no standard protocol that lets agent natively understand each other capabilities. One agent might return JSON, another might return a standard markdown, and third might output something entirely different. So there is no semantic handshake happening between agents today. And then the most important challenge is scaling problem. As you add more agents, you don't get linear growth, you get exponential complexity. So for n agents, you might have to manage up to say, n into n minus 1 integrations path, right? So that's not scalable, especially in enterprise system. And last but not least is difficult to debug and maintain. When something goes wrong, tracing the root cause across these independent agents becomes a nightmare. Logs are scattered, error messages are, you have a lot of error messages. Each agent has got its own error code, convention, and debugging often requires a lot of, tribal knowledge. So in summary, while AI agents are powerful, making them work together today is still a high effort and then an error prone process. And that brings us to why something like Google's agent to agent protocol is such a game changer. And we'll get to that next. So before we get into the actual, technical part of this protocol, let's take a step back and imagine the scene like a university hallway. Here, each professor represents a specialized AI agent. Some are experts in economics, some in biology, some in math, some in computer science, each with their own deep domain expertise. Now notice what they are standing next to these digital kiosks labeled course catalog. Each kiosk is clearly displays what the professor offers. The course name, this is like agent's name. The topic covered, similar to agent capabilities. Office hours, like the availability or endpoint of this agent. And then prerequisites is something like input format or required parameter. Now imagine a student or other professors walking down the hallway, scanning this kiosk. They are not guessing, they are discovering the capabilities dynamically based on what is published there. This is exactly what an agent card in Google's agent to agent protocol enables. Just like a course catalog helps humans to find and connect with the right professor, an agent card allows agents to advertise their skills and other agents to discover and collaborate. No need for any integration code, hard coded API, or tight coupling. It creates an ecosystem where agents can plug in, publish what they do, and let others decide how to engage. Just like a real academic environment fosters, like how this interdisciplinary collaboration. Same thing happens here, like where multiple agents are talking to each other seamlessly without having to write a lot of integration logic. We'll see on how the technical details of how we are going to achieve that next. So before I actually walk through in detail the agents and give you a demo of how it works, let's see, assume that we are having three different agents. One is a crew AI agent. It might be owned by a company A, which is specialized in something. And then we are having a LangGraph agent owned by another company or maybe same company A. Or we are having company C agent, which is, written in say Google ADK. So we're having three different agents. They are written in three different frameworks because we each framework offers some speciality. And then for example for task based we are using mostly Crew AI, and then we want more custom integration, custom orchestration, we are using LangGraph. Like that, no, each company has built their own agent, and these agents specializes in one capability. Now just like we have seen the course catalog in the previous slide where each professor publishes a course catalog, each agent actually publishes its agent card, which tells what that agent is all about. Its capabilities, its endpoints, its schema, the text input format it can accept, output it can provide, it provides all the information. Now, if you have a source agent, if you have some third another agent, this also another agent, this also might have an agent card. Now this can actually, using this Google agent protocol, it can actually discover these agents, okay, and then talk to them directly without any sort of integration logic. Just like if you recall how the model context protocol works for the agents to connect with the tools, right? So basically MCP connects an agent with the tools required without agent have to write a lot of integration logic. Same thing happens here for the A2A protocol. It's just that instead of an agent talking to the tools, an agent is talking to another agent, right? That's the difference between MCP and A2A. MCP helps an individual agent to connect to multiple tools, whereas A2A helps agent to connect with multiple other agents, right? That's the difference. So we will see some of the core components of agent protocol, and then I will start the code walkthrough, and then we'll go through, we'll build one by one agent, and then we'll see how to write the agent card, the A2A server, different components. In the end, we'll build an UI which will connect to these agents and then answer the user queries. So before we get to the actual demo part, let's understand what exactly is the agent card. Agent card, you can assume like a LinkedIn profile for an agent. Just like your LinkedIn has got all your details, your capabilities, the skills, the experience, everything. Similarly, the agent card describes about the agent, its name, the URL, what version it is there, what capabilities does it support, the streaming, it supports a push notification, what are the default input modes, the authentication, output modes, the skills, most importantly, what agent can do with clear description, some examples of how to actually ask this agent, what is the input mode, what is the output mode. It contains everything. Now anyone can read this particular uh, agent card and understand what exactly I can expect from this particular agent. Now in the next slide, we are going to see actual demo. So for our use case, we are building 3 agents. One agent which is specializes in giving you the news. Like you can ask any news about technology or business or markets, it can provide that news. That agent internally uses a Perplexity API to get the news. Then we are having another agent called a weather agent, which would actually give you the weather forecast for a particular city, right? Now we'll have a third agent which will discover these two agents, and depending upon the user question, it will redirect to the appropriate agent. We will see that in the action, okay, in the coming slides. So before we get started, I wanted to go to the GitHub profile, GitHub, and then clone this repo so that you have all the code, any code which I am walking through, you will have all the code. I also provide some instructions here, the project structure, some agents we are using, how it works and everything. So you can actually have this agent, GitHub repo handy. So please clone this repo, so that it helps you when I'm walking through the code. And there is another important repo which is from the Google. In fact, I reuse a lot of code which I'm using it today from this repo. We can directly copy paste some of the libraries and everything instead of cloning entire repo. I took only some libraries. So this has got a lot of examples on how to build the agent using Google A2A protocol. They also have a sample web application, and then not only that, it also has got a lot of key concepts like what is different between A2A and MCP, and then how does agent discovery works, and yeah, it has got really a lot of. And then you can also see in this repo some good concepts about before you can that would really help you to understand what is an agent card and then what is an A2A. So we are going to see all these things in action. I'm going to walk you through an A2A server, we are going to build in a task, we are going to have a to a client, we are going to see a message, artifact, we are going to see all these things in action, the real code walkthrough. But you learning this concept will really help you if at all you want to know more and you want to build things on your own. Okay, so with that, let's start with our first agent. If we go back to my repo, this is what my project structure is. You are having a backend folder, there's a host, this is where your host agent is going to be, and then I'm having two agents. One is a news agent and a weather agent, and then this common this one I directly got from this repo, Google API repo. So this is a host agent. We'll first go from right to left. Okay, we'll see first the news agent, which is built using LangGraph and OpenAI. This basically it is having only one tool to get latest news. So let me first walk you through that particular agent. So you can go to this one, you can first see the news agent. So I'm going to walk you through the code and then we'll start this agent. So you can see these are all our import libraries. What is most important thing here is that you need to this is like typical LangGraph agent, a React agent. So you can enable, I'm enabling all the API keys, Langsmith and everything for tracing. And then if you want more about the Langsmith, the tracing, I have another video where I explain clearly on how to enable the tracing in Langsmith, how to run the experiments, everything. Please go to that video to understand more about Langsmith. So here I am having only one tool. So any tool will have this decorator, like tool decorator will be there. So I'm having only one tool, which is get latest news. So this tool will actually invoke a query API. This query API is available here, the news API class. What it is doing is it is actually getting the news from the using Perplexity API. Okay, so now it is with invoke, it return the response. This simple tool, our agent is going to use this simple tool. So there is a response format. We are saying that the agent will return the response in this particular format. It will have a status, it will have the actual message. So now this is what the news agent, the system instructions, we are saying you're a news assistant, your job is to use the get latest tools, and most important, we are saying you must use only this tool so that agent will not hallucinate or it doesn't make up things on its own. It will use only the news provided from the latest news tool, and then it summarizes everything. Right now here I'm initializing the model. In this case I'm using OpenAI. For purposely I'm using two models. For one agent I'm using OpenAI, for other model I'm using DeepSeek to demonstrate that how irrespective of the what LLM it is being powered by, we could still have agents communicate with each other. And then we also set the tools here. Here we create a React agent. So we pass the model, we pass the tool. This is a memory, agent memory, and then what is the response format. Okay, so the response format will be defined here. Okay, I'll come to the code when we go to this one. Okay, or you can see here the response format is nothing but we are having a status, we are having message, which we defined previously, the bin. Now we are having an invoke method which would actually now invoke this agent. This will return the agent response. So this is a standard agent written using LangGraph, right? There is not much new in this. So what is new is what we are going to see next, which is server.py. Now we are actually attaching this LangGraph agent to this server. How we are doing this? You can go to server.py. Now these are all the common modules you need to import from that repo. Okay, like A to A server, agent card, agent capabilities, skills, push notification, everything. So this is what makes up your A to A protocol module. Now we are saying that it is kind of the entry point method is a command line method. This particular agent will be running on this port number, right? That's what this means here. So now when we run this particular class, this will start this agent on this port number. Now here you can see that we are defining agent capabilities. Do you have a streaming or push notification? In this case, I disabled streaming. It was a true by default. I disabled false because my client is not, I didn't write my client such a way to handle the streaming part. So for now I disable the streaming part, but push notification I enable, so it just pushes notification to my client. Now this is what the agent skills we are talking about. Basically the ID is get latest news, the name of the agent, what this agent will do. This is very important because the calling agent actually looking at this and determining how to invoke this, right? So we are also giving some examples of when you can use this agent, like what is latest news, giving me sports update, like that. So we are telling other agents like when you can use me. Next is what we are having, agent card. So this agent card is what I told you previous slide, that which will tell the agent, okay, version, the URL, what is the default input mode, the capabilities we defined here, and the skills we defined here. Now then this is something for we are actually now this part is where we actually create A2A server. So to the A2A server I am attaching the state server agent card. I'll come to task manager next. I'm going to walk with the task manager also next, then host and then port. Now once we are done, basically this particular agent will be running on agent card. This is the URL for you to get the agent card. I'm going to show you how the agent card looks like. We'll do some curl command and then show you the agent card. Okay. Now we are done with the agent. Now we'll say server.start. This will start the agent on this particular port. For now it will be localhost and then port number 1010, right? This is running. Now let's go back and check what is a task manager. This task manager is one which actually invoked by other agents to execute the tasks. Okay, so you can see that I'm importing. These are again all coming from the Google A2A library. I'm importing all these things from there. Now so this is if the agent is a streaming agent. That means if you see streaming means like it will send a response as and when you get the response. That's why you see in ChatGPT you will see that the words are being displayed continuously. It is putting line by line, it is printing for you, right? It basically streaming the response to you. But we are not using that right now. But this is actually standard code. You can use the same code pretty much for other agents also, but I will walk you through some key methods like validate request will validate request. So this is import method on send task. This is method will be invoked by other agent. Now you are having this agent. This agent is exposed on a particular port. Now on send task means some other agent which when you want to communicate it, when it sends a message, it will send a message, it will invoke this message, this method. So that's why when you see that, after all this upsert task, update store, task notification, this is where it is actually invoking the agent. So the agent which we created here in the agent.py, okay, this agent is actually invoked in the task manager. So now we are having three things, right? One is our core agent, which is having all the tools, the functionalities. Now we attached this or onboarded this agent to a agent server or A2A server with the agent card. Now when someone queries this agent, they will have that agent card where they can understand what this agent is all about, right? Next, once I have this, I'm all having a task manager. This task manager is used to send the task to an agent. An agent could have multiple things. One agent might have a multiple tools, but we need to tell specific the task to that agent, and then agent will figure out what tools to use for that task. right? That's what a task manager is done. So one which is specialized in something called agent, one which will expose that to the outside world, which is an ATS server, and then task manager is the one which will actually give the task to that particular agent. So this is the agent. Now what we'll do is we'll just go to this folder. We are in the news folder. You simply say Python server. Okay, now hit enter. Okay, now we are going to start this agent. It might take a few minutes. Yeah, now we can see that this agent is started. It is creating a line graph. Now it is listening on localhost 100110. Now let me run the curl command here. You can see, now you can see that I have this curl command. This is nothing but agent card. Okay, so whatever we configured, that agent card is here. That is our curl command. Now similarly, we are also having a weather agent. Okay, for weather agent, I am not using any APIs. I am just hard coding some values in the tool. It is exactly same like news agent. No difference. It's just that it gives you an hard coded weather response for a particular city. It exactly is the same thing, same instructions, format, everything remains same. It is also having a server. We can go to server.pa for weather agent, but here we see that we'll say this is a weather reporter, get weather. This is agent card says gives weather information, right? Exactly same. Now I'm going to start the weather agent also. So now we have these two weather agents running. So now I'm having one news agent, one weather agent. Both of them are running on one. This is running on 1011 port. This is running on 1010 port. Now anyone can send a task to this agent. What is most important word is a task. You can assign a task to this agent, and then that agent can actually perform the task. So far we created two agents, right? One is a news agent which is already running here, and then we created a weather agent which is running here. Now anyone can actually invoke these agents through, even you can send a curl command actually and invoke these agents because they are exposed now. Now we need to have another agent which is a host agent or maybe a client agent which is actually invoking these agents. Instead of using the word invoking, I would say sending the task to these agents depending upon the user query. Now for that purpose, I will first go through this host agent.py, then I'll walk you through remote agent. Now let's check this one. This is also in another agent. This agent is using Google ADK. Okay, now we have seen two agents, LangGraph agent for news using OpenAI, and then I'm having weather agent using DeepSeek. Now I'm having this Google ADK using Gemini, right? So I'm having three different agents using three different LLMs altogether as base. Now you can see that I'm importing all these classes required. So what is most important is I'm defining the host agent. I will actually walk you through the agent definition, which would cover everything. Okay, so first go to the create agent. I'll tell you where we are getting all these things. So here we are getting this agent. Basically this is the agent which your UI is talking to, right? This is the agent which will communicate with all other agents and get you the information you want. So this agent is your entry point. So we are defining this as a model we are using. We are giving some name for this one, and then we are giving the instruction for this agent. Very important. Let's see what instruction we are giving for this agent. We are saying you are an export delegator that can delegate the user request. Discovery, to discover the agent, use this list remote agent to list all available remote agents. You can use delegate the task. Execution, you can create a task to assign the task to remote agent to perform. Okay, and then you can say you check pending task to check. So please rely on tools, the request. So something we are giving all the instructions to agent. This is the instruction for this agent. Okay, then we are having another call before model callback. Okay, this is what happens before actually having LLM, like this is very having some setting a session state and session ID. Okay, and then we are giving some description for this agent, and most important thing is that see the tools part. If you see other agent also has a tools, but this agent is having tools also some other agents. Now let's see what tools it is having. This is having a tool called list remote agent. This will list all the remote agents which are available for this host agent. How we are getting this remote agent? You can see that remote agent name, everything it is getting. Okay, so self.remote agent connection. Okay, so we'll go to remote agent connection. I want to get into the remote agent connection right now, but for now you think that this get list remote agent method somehow fetches you all the remote agents, its agent card, its name, description, everything. Right now this is again going back to agent. It is having another tool called send task. Now see how this agent works. This agent is only using list remote agents to identify what agents I am having, and then it is using send task method to send the task to that particular agent. Now how does it determine which agent to use? That is the intelligence built in the agent, because depending upon the user question, if the user asks what is happening in the US markets today, it knows that looking at the question, it knows that I have to invoke a news agent, because it has got the news agent card which says anything related news you call me. If I ask you what is the weather in this city today, a particular city today, or like what is the weather in Dallas today, then it knows that since the weather user is asking, I have to use a weather agent. That's intelligence is what this agent is already having because of the base LLM, and because we are telling the tools. Now if you go to send task method, this will actually assign the task to the agent chosen by this. For example, I have two agents, news and weather. For a particular user question, if this host agent decided to use a news agent, this send task method will send the task to that particular agent. Okay, so this is about the agent. Okay, maybe this lot of code is there. It takes a lot of time to walk you through all the lines, but you can actually review this code. Even if you're having some tools like Windsurf or Cursor, you can actually highlight the method. It can give you what exactly is happening in this tool. Like for example, I use Windsurf tool, so you can actually ask it, like you can just mouse more and say explain. It will give you some explanation of what exactly this method does, right? It gives you all the details about this agent, and then all the where exactly it's coming from. It's quite useful for you if at all you want to understand this code part. Okay, let's going back. So going back to our this one, then we are having another class called remote agent connection. So this is which will connect this host agent with the remote agents. Okay, so again this class also, if you can see send task, is basically when the host agent says send task, this is being used by it is internally invoking the this remote agent. Now you can see there are two types of streaming. Looking at if the agent is having a streaming capability, it goes to this loop. Since we disable the streaming, it will go inside this else condition. Look, I actually added all this print statement for me to understand how the agent works and everything. So it gives you the response, and then that what a response it gets, it sends back to the calling agent. Okay, some merge metadata, everything. You can go through this code. You can use explain method, which will clearly explain you what exactly this method is doing. Okay, and then now I'm having host agent. Now time has come. I need to communicate the host agent through some that's where I exposed this particular agent as an API, right? Because now I don't have to really worry about all other agents. The only one agent, which is my entry point agent, which I have to talk, my UI has to talk, only that agent I'm exposing, because this is within my control, this is within my system. I'm not interacting with other agent. This agent is not I'm interacting with one agent. Now you can see that there is nowhere we have a direct integration code to that agent, right? You are only telling this agent this is a list of available agents, and it know by looking at the agent card, the agent knows like what method the agent is having. Based on that, it is internally making the calls automatically. So you are not making any API call to other agent here, right? That's the beauty of this agent protocol. Now let's go to server.py. This is nothing but a fast API call. One thing I did is to create a simple UI. I have two, both you can query like a direct query, asynchronous, and I also expose them as a WebSockets. So with WebSockets, you could between the browser and server you have WebSocket connection established, and then this is typically used if you want to build a system where you want to chat, where you want to keep that connection between the client and server instead of starting that connection every time. So we have the WebSockets. So I expose this WebSockets connection and everything is there here. This is like a standard API call, not much new. Then we run this particular API on port number 880. Let me show you. Yeah, basically quickly I'll show you, walk you through this code. Yeah, what is most important thing here, I'm telling these are my remote agents, the agents I want to connect. So I'm passing these remote agent addresses here. So just like that, this is a proof of concept. Maybe I have to defining here. I'm assuming that sometime in the future we will have registries where we publish all the remote agents. So I don't have to manually pass all the agents I want to connect like a list like this. I can actually query the registry might have all the remote agents, and then I connect to them using the connection. So you can, that's what we are doing here. You can see here I'm actually creating a host agent here by passing remote agents, and then I'm saying create agent. Right now this host agent knows that it will connect to these two agents, get their agent card, discover them, understand what agents they are available, what they can do, and it will use them. Now we are having this also. Let's run the server.api now. So now this will run the host agent on a particular, that means now we can send a message to host agent through a particular port. Yeah, now we can see that this agent is running on 8080, right? Now let's do a recap. So we are having a news agent which is running on 1010. So we created a news agent in LangGraph. We attached that news agent to an AWS server, and that agent is running on this port. Now I'm having a host agent. This is all which will give me I'm having weather agent which will give me all weather. We attach this also AWS server, and then this is running on 111 port. Now I'm having a host agent which is connecting to these two remote agents, right? So all we require now is a simple UI where I can actually execute, send a request to these particular agents. Okay, let's go back to the UI now. So I'm having a simple UI here, right? So now it says connect WebSocket server. Now we can enter any command like what is, say latest news in AI. this week. Okay, I will, once I hit the button, I'll just go back and show you how the agent logs. That gives an idea like how the agent is picking up the right agent. Now I click send query. Let's go back and check what is happening here. Now you can see here that this agent has received the request now, right? So first this has come to this agent. It opened the website connection here. Okay, now this agent, it figured out, it got this agent card here, right? Now it sent this agent to this agent. Now the news agent is working on using the tool called get latest news with the topic AI, right? Now it got all the latest news from the Perplexity. Now the agent is actually summarizing all the text it has got from the Perplexity and then sending it back to this agent, right? And then this will display this in the UI. Okay, so basically I'm just doing some truncating of the text to avoid not display, so you're seeing very limited text coming out of this particular in the UI. Now let's see another way. Now we have to invoke a weather agent, right? So let me ask this question like what is the weather in Dallas today? Now I'll hit send. I'll again go back and see like which agent is invoked. So I'll hit send here. Now go back to our first agent. Now it can see that now it is actually pulled the weather agent card, send it as weather agent. This is my weather agent. It is invoking this tool called get weather for city Dallas. So it got the response because it's a hardcode response, it got quickly. Now it is sending that response to the DeepSeek LLM. Now it is summarized. This agent has finished the response. It's sent the response back to this WebSocket. Now if you can go and see in the UI, it displays this response back here. So as you can see, this particular host agent is connecting to what is most important thing you have to notice is here is that depending upon the user response, user question, it is sending the request to that particular agent. So when I ask the question like what is the weather in Dallas, it knows that it has to use this weather agent and it has sent this message to weather agent, and then this is a send task. Okay, so it is sending the task to this agent. So and then since it is a non-streaming, you can see the response it has got. These are all some kind of printing I have done to show you this one, and then this is a response it got. We are extracting the response and then sending it back to the WebSockets, right? So this is about the agent protocol. And then I have all this code in the repo. Please let me know. I also have a clear instructions on how you can set up this repo in your machine. If you have any challenges, please let me know. Okay. Yeah, that's all this demo. Okay, that's end of the demo. Hope you enjoyed it. Please feel free to post any questions you have on the demo. I'll be leaving the GitHub repo link in the comments of this video. And then please, if you have any challenges in working with the code, please add your comments there. Thank you.